Hello everyone. Today we will start lecture 16 of module 5, that is on flood studies. So in this lecture you will learn about remote sensing for floods. So this is the part 1 of lecture 16, and in this lecture I will try to refer some of the case studies, some of the examples from the published literatures, and that will help you to understand how remote sensing and GIS are used in flood studies. So before we continue, just let us go back and just try to understand this flood. So a flood is the inundation of a normally dry region caused by an increase in water in a river or stream, right? So here you can see these examples, these are the real examples. So here floods can be destructive and unpredictable, necessitating effective monitoring ranging from widespread river floods to localized flash floods. So as I mentioned earlier also, that flood is a deadly natural disaster, but it has both aspects, negative and positive. Since it causes to lose lives and property, we try to go for the monitoring and prediction, right? So the climate change and anthropogenic activities are increasing the frequency and intensity of the flood event. So we all know that our human interventions are more, so that's why these natural processes are getting disturbed, right? And because of that we are having more frequent floods, right? The growing impact of floods demands integrated and proactive risk management strategies. To save the lives and property, we have to be proactive and we have to utilize the recent advancement in the technologies so that our prediction and modeling will be more accurate. Sudden events like flash flood provide little to no warning time, because you can see if there is a breach of dam, right, and it is because of some unforeseen causes, so you will have no warning, you will not have any time to rescue, right. So in such condition, eyewitness reports are often the only source for small scale floods. So many times in the isolated areas, only the eyewitness reports or the people who are living in the surrounding, they only report such cases, right. Limited stream gauge data in remote areas hinder real time monitoring, because to monitor or to model the flood event, we need to have the in situ measurement, but because of the scarcity in the in situ data, that real time monitoring is not possible, and especially for the isolated areas. So because of this reason, satellite data bridge this gap, especially in inaccessible region. So there remote sensing comes into the picture, and remote sensing can help to model or predict or to identify the flood events. Here you can see this is one example, right. So this is before the flood and this is after the flood. So remote sensing plays a crucial role in flood monitoring and management by providing frequent and synoptic observation of the earth surfaces, enabling flood mapping, inundation monitoring and even damage assessment, because here you can also go for the damage assessment, because you will have pre and post event data sets. This is another example. So here you can see this is elevation which is here, right, and here you can have the precipitation and this is the time, right. So how this precipitation is happening in this particular region, then you have annual rainfall and this is the year, right. Here it was month, here it is year, and this is the blue color is showing the river, and this is the flood inventory, that stars. These are the reported flood data sets, right. So here with this information you can also go for the comprehensive observation. So, it provides a broad view of the earth surface, monitoring large area with frequent updates, because when you are having the remote sensing data, very frequently we are acquiring the data, and all the data set that have been acquired, that will be stored in the archive, right. Crucial for understanding flood dynamics, because if you want to understand the flood dynamics, you need to have the historical data sets. So, one thing, that is the location of the event, then how it occurred, what happened, what was the pre and post conditions, those things will be available to you through remote sensing data sets, right. When we talk about the flood mapping and monitoring, the satellite data identify the map flooded areas, track the extent of flooding over time, helps in near real time disaster management. Here I am not writing real time, it is near real time, right. So, please remember that with remote sensing data we can go for the near real time, not real time, because there will be a gap between the acquisition, your data downloading, and then your usability of this data into your model. So, let us understand the importance of the remote sensing. So, here you can go for the flood prediction, uses historical data and current conditions for the flood prediction. It helps to forecast potential flood and assess risk. It also helps to forecast potential floods and assess the risk. And the next is the damage assessment. So, where we evaluate the infrastructure damage after a flood event and assist in disaster response and recovery, right. So, here you can see this particular map, here you have different classes, right. So, these classes are having different color code, and these color codes can be used to understand whether your area, whether it belongs to very low, low, moderate, high or very high category, right. So, this kind of flood prediction or the flood modeling can be done with the help of remote sensing and in situ measurements. Spatio-temporal reconstruction of floods. Remote sensing allows for detailed mapping of flood evolution over time. So, because we have the data set since let us say 1980s, right, and we are in 2025. Now, for this time period, at least we have various data set from various sources. So, those resources can be utilized to identify how a particular area is experiencing the flood over the time and how each time the flood behaved, right. So, those things can be assessed using the remote sensing data set. Multi-temporal data captures flood spread and recession phases, helping to understand flood behavior in areas lacking historical record. Because as I mentioned in the previous slide, if an area does not have the in situ measurement unit, right, or there is no government officials involved in this measurement, then this will be only based on the local people who are living in that area. They will be reporting that there was a flood event, but you will not have the data. But with the multi-temporal data set from the remote sensing sensors, this flood spread, how it has spread, right. If this is the active channel, during the flood, what was the flood plain, how much time it took to come to the normal phase, then how it behaved, right. So, those things can be assessed with the archive data sets. Time series satellite images create a visual narrative of the flood event, because many times what happens, we try to utilize this satellite images with DM and then we try to go for the hydrodynamic modeling. and then you will be able to visualize actually what happened and how it occurred, what are the area got flooded, how much water was there, how people have survived in that particular region. Remote sensing detects erosion, sediment deposition and debris flow and reveals runoff generation pattern as indicators of flood strength and extent, right. So, here remote sensing can help you to identify the erosional places, whether a particular reach is having the erosion. So, this particular reach was having the maximum bank erosion. Then sediment deposition, what are the areas which received the sediment during this flood which got deposited. So, you will easily identify them. Debris flow can also be monitored, and then you can also have the synoptic view of this particular area, right, because of the spatio-temporal data set. These studies helps to reconstruct ancient and undocumented floods, enabling estimation of historical flood magnitudes. And the accurate paleo-flood means the historical floods, records may help in modeling future flood scenario, because as you know that many of us are involved in these days artificial intelligence or machine learning or deep learning methods, where we are utilizing all these data sets and we are trying to predict the future events, right. So, in such cases this historical data set will help you to model it with high accuracy. In this particular slide, this map is showing the flood risk map, and here you can see that this is green color is very low, yellow or maybe light green, that is low, then orange is moderate and this color is high. So, here these areas are nicely representing whether your area is in the low zone or high zone or moderate zone, right. So, this is the flood risk map. So, to go for the flood risk assessment, there is a framework. So, what we do for flood risk assessment, we first go for the identification of the elements at risk, right. Then we go for the flood hazard assessment, and then third is the vulnerability assessment. Once you have these three, then you can go for the flood risk assessment, right. Here you can see the flood monitoring have different components, right. So, it has three stages. The first one is the forecast, second one is the emergency monitoring, and the third one is the damage assessment, right. So, these stages occur before, during and after flood event respectively. So, for a particular flood event, we have to see what is the scenario before, during and after the flood event, right. So, despite the temporal divisions, all three are highly interconnected, because forecasting, emergency monitoring, damage assessment, these are highly interconnected, because all are, we are talking about the same event. Improved forecasting leads to better emergency responses and more accurate damage assessment, because the more you have the accuracy in your prediction, you will be able to intimate the people who are residing in that particular area well before the event, and then they will be able to save their life and property, right. Then comes the forecasting. So, here forecast primarily rely on meteorological model and satellite data. So, we try to gather the information related to precipitation and the wind speed and the cloud condition on this meteorological parameter, and the satellite data sets are involved in monitoring these events. Low to medium resolution optical dataset is often used for large scale weather and rainfall pattern, because till now I have covered in several slides that remote sensing is one of the primary source to generate this meteorological parameters, right. So, accurate forecast and early warning helps to predict flood prone areas in advance, which drastically reduce the human and infrastructure losses. In India, the Central Water Commission CWC provides 5-day advance flood forecast for 20 major rivers in India. I have also given a detailed introduction about the CWC in the previous lectures. So, I hope you will remember and recall all the concepts, and you will be able to understand how CWC is involved in predicting these events. Forecasts are generated using data from GFS, which is Global Forecast System, and WRF, Weather Research and Forecasting Methods, right. The in-house developed model system is automatically updated every 3 hours for all stations during the monsoon season. So, all the in situ measurements are connected to the base station. Also, the satellite data sets are accessed, and these models are updated at every 3 hours, right. Forecast model integrate real time rainfall data to provide actionable flood alerts, aiding early warning and mitigation efforts. Many times you might be receiving a message that now there will be a strong thunderstorm or rainfall, so don't walk or don't leave your houses, something like that you might have received. So, that is the communications, right. Because of this prediction, it is getting intimated to the people who are residing in that particular area. Additionally, a near real time inundation forecast is being developed for the Ganga basin under the National Hydrology Project NHP, utilizing high resolution DM from NRSC, Survey of India and other state government offices, right. So, we are in the process for developing this kind of system for Ganga basin, and hopefully we will be able to save the life and property more effectively. Then comes the emergency flood monitoring. High resolution data set. When I am saying high resolution data set, that means high spatial resolution data set, right, because the width of the river is not so high everywhere. So, we have to have high spatial resolution data set. So, high resolution data from optical and radar sensor during flood provides fast and reliable monitoring for disaster response. So, here you can see the example. This is from Germany, this is from China, this is from Peru, how the optical remote sensing data sets are used. Here you have Landsat and Sentinel-2, right. And here you can see the black color in these images are representing the invalid, that is cloud or shadow, and this light blue is flood water and this dark blue is the permanent water. Optical sensor may face limitation due to cloud and poor lighting, because we all know that optical remote sensing have its own limitation. So, therefore, the use of synthetic aperture radar is ideal due to its cloud penetration and day night observation capabilities. We all know that synthetic aperture radar uses the microwave wavelength, right, which is high wavelength. So, in the high wavelength region, this cloud coverage is not a problem, scattering can be minimized, and also we are talking about the active SAR. So, the day night observation is possible, right. So, during a flood event, what happens? It generally occurs in the monsoon period when you are having the cloudy sky and the illumination condition is not so good. So, optical remote sensing has its own limitation. In such cases, microwave remote sensing can be of great help. Let us talk about the damage assessment post flood. So, remote sensing provide spatial data aiding the assessment of the extent of damage in affected areas, erosion and the infrastructure post flood, right. Multi-temporal analysis helps to track changes over time, facilitating recovery strategies and future risk reduction. So, here this is one example, you can see this particular boundary. So, this is the pre-event and this is the post-event. Now, here you can see that visually it is very clear that after this flood, this particular area has been changed drastically, right. So, this is what I meant, that pre and post event data sets are available from the space that will help you to analyze the changes, right. So, the integration of monitoring stages. So, we have monitoring, then assessment, then we have forecast, right. So, we start with monitoring, then we go for the assessment and then we go for the forecast. So, the forecast guide emergency teams to high risk zones. The emergency monitoring data helps to validate and refine forecast, and the damage data feeds back into model to improve the prediction accuracy, right. So, this continuous cycle enhances long term flood preparedness. So, if this has been developed for a particular location or a particular section of the river, then over that time this model can be retrained and the accuracy can be increased, right. So, let us talk about the optical remote sensing application. So, the optical remote sensing captures reflected radiation across visible to infrared bands. I hope you remember that when we talk about the optical remote sensing, we referred to the reflected and emitted domains, right. So, when we talk about the reflected domain, it is from 0.4 micrometer to 2.5 micrometer, and here basically we get the surface reflection, and this reflection will give you the surface information. It will not give you the subsurface information, remember it. So, it performs well in rural and natural areas under clear sky condition, because we are talking about the relatively shorter wavelengths, which is greatly affected by the scattering and the absorption, and also because of the presence of the clouds, right. Water appears dark due to low reflectance, aiding flood detection. So, if fortunately this data is available without any cloud cover or with very limited cloud cover, in such cases the water will appear in the blue or the dark color, right. So, that will help you to identify the flooded zones. So, optical remote sensing is limited by cloud cover, especially during flood event, because that time mostly we have this cloud coverage, and also the lightning condition will not be good. So, condition like turbidity, sun glint and wind can also affect the detection accuracy, because that will hinder this measurement, right. So, because of that, optical remote sensing have limited application in the flood studies. However, if the data set is available, then it can be used, right. Then comes the thermal remote sensing, which is also the optical remote sensing. So, here you can see the water has low reflectance in the thermal and infrared ranges, right. So, that can be used to identify the water from other dark areas, right, because shadow will also be there in the optical remote sensing. So, this can be used to distinguish water from other dark surfaces like shadow, useful in detecting shallow or turbid water that is not easily visible otherwise, right. It also enhances reliability in high reflectance environment like cities, because here we are talking about the emission and the wavelength is 2.5 micrometer to 16 micrometer, but generally we refer 3 to 16 micrometer because 2.5 to 3 micrometer is the overlapping region between the reflectance and emittance, right. So, because of this reason we use this 3 to 16 micrometer, but in some of the book you may find 2.5 to 16 micrometer. So, both are correct. Then comes the surface temperature. So, the object above 0 degree Kelvin. So, when we talk about the thermal remote sensing, the surface temperature is the key. So, the object above 0 degree Kelvin emit radiation. Why? Because we have to maintain the equilibrium with the surrounding. So, whatever energy we have gained through the solar radiation or from any other external temperature, that will be released to maintain our temperature with the surrounding, and in this case what happens, the emission will occur and that emitted energy will be measured by your sensor. So, in thermal remote sensing we measure the radiant energy, right. The digital elevation model, which is another very important source of information when we talk about the flood studies, because here it gives you the information about the topography. So, here this is available along with the latitude and longitude that will exactly or accurately provide you the information about the elevation of that particular point. Digital elevation models represent the Earth's surface elevation, which is vital for geospatial analysis and is generated using remote sensing technologies, right. So, various methods are there: conversion of contour lines, photogrammetry like satellite stereo pairs dataset, radar interferometry and laser altimetry are the various methods for DEM generation. And the topographic and hydrological information extracted from this DEM is very common. In addition, its product like slope, aspect and basin information are widely used in many application. It is not only in the water resources, it is not only in the flood studies. This application of these information are very important or very crucial in many other hazard studies. So, this is one example. So, this is a satellite image captured from a satellite, and this is the DEM generated from, let us consider from any source you have digital elevation model. So, once you see them separately, you will have the information that this point and this point are same. So, you have to refer both the images one by one to know what is the land use land cover and what is the elevation. But in GIS we can integrate them together and then we can find that this particular location is having this elevation, right. So, this is the 3D modeling of that particular area, and here you can go for the hydrodynamic modeling, and then you will be precisely knowing if you have one glass of water, then whether it will flow in this direction or this direction, because you know the slope as well as the aspect, right. So, this is the application of remote sensing data set. Now, the optical stereo based DEMs. So, these are the optical stereo based DEMs: Aster, Cartosat, ALOS Pulsar, then Spot DEM. There are various sources for this digital elevation model. Then INSAR based DEMs, SRTM, Tandem X, then Copernicus DEM, these are available, right. Airborne and LIDAR derived DEMs. So, you have these DEMs derived from LIDAR, right, and the resolution is also mentioned here. So, when we talk about the watershed modeling, this digital elevation model and the stream network, also the satellite images, they play crucial role, and then you can have the 3D modeling of this particular watershed. So, large river with several tributaries are typically called river basin, whereas watersheds are used for tributaries or small streams. So, once we have all these data sets for the entire drainage system, then we can go for the watershed modeling. So there are different flood controlling factors. So here you can see the rainfall, geomorphology and other hazards, then soil, elevation, slope, curvature, flow direction, stream density, distance from river and road, land use land cover, NDWI, NDVI, TWI. So these are very important in flood studies. So with this I will finish this part 1 of this lecture, and we will continue this in the next part of this lecture. Thank you very much.